Let's learn how to change the brightness level of an LED light. Next thing we have to add is from time import sleep, as we're going to use this sleep command in that while true loop to make sure that we're able to wait a second before something else happens. Next, we're going to nickname the LED, and it's called PWM LED, all in capital letters, and we have to tell which GPIO port we're currently in. For my GPIO pin right now, I'm currently plugged into port number 26, which is all the way at the bottom left. So I am right there in 26, and I have the ground port for my other cord, and that's what's plugged in right now. So I'm going to specify for me 26. Ultimately, you'll choose what your circuit is plugged into. See a previous video to how to make that circuit. Next, we're going to write while in lowercase, capital T in true, and then colon at the end again, which is again shift and colon. You're going to then write LED.value space equals 1. And 1 is essentially full brightness, and sleep for 1 second. Make sure that you indent this, because when you start by typing it, it'll be aligned on the left. So you have to hit the tab key 1 time to space that out so that you're showing that these commands are both inside of this while loop. Then if I click run for this program, we'll notice my LED light is on at its maximum brightness, which is also currently dependent upon the resistor. So the more resistance, the less bright this will be. Right now, the resistor I'm using is 82 ohms. For comparison, I've now swapped out this to be a resistor that has 2,200 ohms of resistance. The bands over here determine the amount of how much it absorbs, and we'll notice the light is significantly less bright, even though I haven't changed the PWM value. Kind of cool to play around with different resistors, because we go all the way from 0 ohms of resistance all the way up to 1,000,000 ohms of resistance. We have plenty of different amounts, so you can play around with those as long as it's more than 50 ohms, which makes it safe to use. So in order to adjust from full brightness, which is at 1, down to 1/10 the amount of brightness, what we're going to do is we are going to change that number from 1 to simply 0.1. And then what I'll do is I'll stop the program from running, and then I'm going to click run, and you'll notice when I rerun this right now, it looks much dimmer. And if you kind of look at it, it almost seems like it's flashing until you really get close in on it. The appearance of this being flashing is due to the fact that this LED is being turned on and off rapidly, with the length of time that it is on changing based off of the PWM value, which is currently set to 0.1, which is what's making there less light, but also makes it seem like it's flashing. Essentially, PWN is a technique that's used to control the amount of power supplied by the LED by rapidly turning it on and off. When that value is changed, the ratio of on to off is changing, which makes it look like it's flashing or flickering, especially at low PWN values, or if there's a rapid change in this PWN value. So let's make this actually rapidly change to get a feel for what's happening. If I modify my loop to have the value be at 0.05, a really small amount, then sleep for 1 second, and then change the LED value to be 1, so it's fully bright at maximum brightness, and then sleep for 1 second. If I run that program, we're going to get something that looks like this, where it's on in the lowest amount, and it repeats over and over forever. We really see that flickering at that low value. But let's take a look what happens if we decrease the sleep time to something like 0.1. So I've now modified the code so that I have a sleep value of only 0.1. Then I'm changing the LED value to 1, which is going to be maximum brightness. And then I'm sleeping for another 0.1 second. So I've stopped my old program and I clicked run to run this program. And this is the effect that we get, which looks kind of funky, but it's changing from a PWM value of 0.05, so basically really small, all the way up to maximum brightness. And we're getting this flickering effect because of the changing on and off of how much electricity is being allowed through there. I further modified the code so that I have now an LED value of 0.1, then sleep for only 0.1 seconds. Then I increase the value to 0.5, which is half brightness, sleep for another 0.1 seconds. Then I make it full brightness, sleep for 0.1 seconds, and then I have the value set to off. So when I click run to run this program, this, after I stop it and rerun it, is going to give us an effect that looks like this, where the value every 0.4 seconds is going from off to on, kind of like pulsing, which is kind of cool. Don't want to set these values manually. We can get rid of the entire loop and we can add in led.pulse and then put a pause command afterwards. Add from signal, import pause, and now we're able to use this pulse and pause that we've used one time before. If I stop the program and then run it, we'll notice it's going to be able to pulse all the way to a maximum value of 1, all the way down to a value of 0, and we can really see that flickering when it changes rapidly, like I mentioned more. The faster that those values change, the more it's going to really seem like it's pulsing. The closer we zoom in, the less that appeared effect is going to happen, and you can see the pulsing more. But we can really see that cameras pick up on that effect. Pretty cool. Like our own lava lamp.